Greetings everyone. So now we are going to discuss about three major phenomena through which the heat can be transferred. So there are three mode of transfer of heat, which number one includes conduction, number two includes convection, and number three includes radiation. We just discuss with start with conduction. Let's suppose if we take a frying pan. That frying pan has got, one side of it is under the burner, and being hot, and the other side is the handle, right? So after a few minutes we just realize that, even though the burner is only exposed to the pan of the frying pan, but the handle after a few minutes also gets as hot as the burner. Reason behind it is that it is a phenomenon of conduction occurring in which heat is transferred from one molecule to another through direct contact. So what actually conduction is and what actually happens in conduction is that conduction is the phenomena, it is a process in which the transfer of energy in the form of heat occurs from one body to another body, or from one part of a body to another part of a body through direct contact. It Now, one major difference between conduction and convection over here is that conduction is a process in which transfer of heat occurs through direct contact without the transfer of matter, which means transfer of matter does not occur. Only the transfer of heat occurs from level of higher temperature to lower temperature, from the higher energy state to lower energy state. Now, as you may see, the energy is being transferred from one molecule to another molecule, but the molecules are themselves not moving anywhere. They are just vibrating around their position back and forth. It's only the transfer of energy in the form of heat which is occurring from one molecule to another molecule, which causes the other part of the metal, which causes the other part of the handle of the frying pan to become hot. So in that sense, the conditions for conduction are two, which includes the temperature, and number two includes direct contact. The molecules should be in direct contact, and there should be a temperature difference, alongside which the transfer of heat should occur without transfer of matter. Matter will not be moving. There will be movement of heat only from one part of the matter, from the higher energy state of the matter to lower energy state of the matter. If we talk about convection, convection is a process in which the transfer of energy occurs by the transfer of matter. For example, if there is high heat energy in molecule A, then in order to transfer energy in the form of heat, what molecule A will do is that molecule A will move from its high energy state, excited state, to lower state, and at that moment when it will move from excited state to lower state, it will cause to release energy in the form of heat, which would be considered as a process of convection. Now, convection basically occurs in liquids and gases. The reason behind it is that their molecules are allowed to freely move, due to which they can easily transfer heat from one part to another part by movement of matter as well. But if we talk about conduction only occurs with solids. So even in solids, it only occurs in metals. It occurs in non-metals and non-metals as well, but non-metals are poor conductors of heat because of their molecules being tightly packed, as well as there are no free electrons moving. So you know it's important to have metals if we want a good conductor. And metalloids are average conductors. They are neither too good nor too bad, and they have characteristics similar to metal, but again some characteristics similar to non-metal as well. If we talk about symbol of conduction, it is H. Now, H, if we talk about the mathematical derivation of um, conduction, then conduction can be considered mathematically, that if whenever we are taking a material of high thickness, then if let's suppose if we are taking a slab of 20 centimeters, then at that moment the conduction would be less. If we are taking a slab of 2 centimeter thickness, then conduction would be high because it is having less thickness, less, due to which there is less area. So we can say that if thickness is high, conduction is low, and if thickness is low, conduction is high. So if we talk about thickness, we can simply say that conduction is inversely proportional to thickness, which is represented by delta x. On the other side, if we talk about conduction, on the other hand side, if we talk about another phenomena is temperature. If we are having higher change in temperature, if change in temperature is high, then conduction would be higher as well. And if we talk about another phenomena, if of surface area, if surface area is high, let's suppose if this frying pan in this diagram is having this much amount of surface area, but what if I put a plate, if I put a dinner plate over this you know burner, or even if I simply plate um, a big frying pan which is having a larger surface area than this, then at that moment conduction would be increased. So in that sense, conduction would be increased if there is high surface area. So conduction is directly proportional to surface area. Now when we combine all of these three equations, what we get is H is directly proportional to delta T A upon delta x. Now within this formula, when we are supposed to remove the proportionality constant, what we actually get is when we are going to remove the proportionality sign, we'll get a proportionality constant known as k. Now k over here is basically what we call as a proportionality constant, and when it comes to its significance is such that it is a thermal conductivity constant. It is a thermal conductivity constant, which is itself made up, having its own formula, which is known as k is equals to L upon R. Now k is a thermal conductivity constant, L is the thickness, and R is the thermal resistivity constant. So we can simply say that thermal conductivity is inversely proportional to thermal resistivity. And if we simply talk about thickness would be the same as del x. It's only for showing that there's a difference, so that the symbols don't mix up. When it comes to R, R is thermal resistivity constant. Now, what does R signify? R basically signifies that whenever there is that the R basically signifies that the amount of heat which is passed in 1 second through one phase of um, uh, one phase of a container having its area equal to 1 centimeter square with its, so I can simply write that down as well. That's the amount of heat that flows through one oops, amount of heat that flows through one face of 1 centimeter square of a body, through one amount of heat that flows through one face of 1 centimeter square of a body through 1 centimeter square of a body in 1 second in 1 second is called the thermal resistivity. So thermal resistivity itself depends on the physical properties of the material, as well as depends on the thickness of the material, as well as what we call as the thickness of the material. So thickness of the material and thermal resistivity are related. On the other side, resistivity is itself dependent on the physical properties of the material. Let's say if we talk about metals have less value of thermal resistivity as compared to non-metals. Insulators are having more value of thermal resistivity and less value of conductance, and why vice versa, we are having thermal, metals or conductors are having high value of conductivity and less value of resistivity. So in that sense, this is how we classify it. That's all about today's video. Hopefully we will meet in another video.